Good morning, everybody. This is Jasper Snyder, and this morning I'm going to be talking to you about how to enrich social data for market research. So these are the sorts of questions that we want to answer today in the presentation. First of all, what sorts of questions can social media research and analysis answer? Secondly, how do you go from a huge amount of un- and semi-structured documents to actionable market research insights? Third, how can social media-based market research be tailored to different and individual client and use cases? And fourth, how does machine learning work, and why does it matter for market research? So the overall goal here is to help you understand the questions and factors you need to consider when you're looking at using social data for market research purposes. And also to help you understand, we're talking about machine learning there, to help you understand some of the key technologies and techniques in this field. So social media research can support both traditional market research goals and PR functions. So on the one hand, social media research is a great tool for answering traditional market research questions, such as finding out what people think about products and brands, understanding market awareness of products and brands, and potentially also looking at purchase triggers too. The fact that social media data is unprompted and unstructured, however, is both a challenge and a unique opportunity. So for this type of use case, the research use case, the primary aim is to understand what consumers think. On the other hand, social media can be a great input for PR and customer service use cases. And for this type of situation, the goal is less to understand the population and more to, for example, detect any and all potential customer complaints about a product in order to head up a potential PR process. Another example might be if you're a pharmaceutical company, you might want to learn about any adverse reaction to a drug. So in summary, in terms of PR, we're looking at stuff like consumer complaints and product malfunctions, crisis monitoring and response, and reputation management. So these two use cases, market research and the PR or comms side of things, closely align with two services, which I'm going to characterize here as social listening and social media monitoring. And they're kind of distinct in terms of their needs and requirements. So social listening, as we've gone through, is really, the primary goal is to understand a consumer segment or market, and potentially extrapolating from that what a population out there in the world thinks. And in terms of its requirements, it has a much higher tolerance for missing content. It doesn't need necessarily to be absolutely comprehensive. However, the other side of the coin is it has a much lower tolerance for irrelevant content. So when you're analyzing a set of data, you don't want 60% to be absolutely non-germane or non-pertinent. In terms of social media monitoring, however, they use the type of service that supports PR and communications. The goals are kind of different. The goal here is comprehensive real-time coverage, and there's a much higher tolerance for irrelevant content because likely you'll be weeding through it, but a much lower tolerance for missing content. So if you miss a customer complaint or you miss an adverse event or something akin to that, then that's really that's a failure of the service you're using there. For the remainder of the presentation, however, we're going to focus on the first type of use case, the social listening. And the social media research process is really comprises three basic stages: data collection, data enrichment, and analysis and insight generation. And in the rest of the presentation, we're going to consider the question of how you can boost the scalability and accuracy of your research methodology by introducing machine learning approaches. So as a result of that, we're going to focus mainly on data collection and enrichment, the first two stages here, because these are the stages where machine learning is the most applicable. Further, we'll see that many of the steps in the research process are really at their core sorting tasks. And it so happens that machine learning and computers in general are very good indeed at sorting tasks. So for the rest of the presentation, we'll go through and we'll hopefully understand how and why that's the case. So looking first at social data collection, the goal here is to identify and acquire the data that can answer your business questions. For instance, let's imagine a marketer for an automotive company that will soon release a new hybrid vehicle, let's say, and they want to learn more about hybrid vehicle consumers and their attitudes and self-reported behaviors surrounding those vehicles. There's a world of social media documents out that this marketer needs to collect in order to answer these questions. So in the data collection stage, the first task is to identify the key online venues for consumer conversation about hybrid vehicles, and from these sites to pull in the universe of documents that are relevant to this topic, while excluding those that are irrelevant. Now, eliminating spam and irrelevant content are very good candidates indeed for machine learning. Going on to the data enrichment step, as the goal here is to look at the document and potentially the sub-document pieces of that document and enrich it with classifications for topic, for consumer segment, emotion, etc., etc. We'll go on to that in a bit more detail later in the presentation. Basically, as a marketer for the automotive company in our example, in order to better craft your marketing and advertising, you basically want to learn more about the consumers who purchase and who are interested in hybrid cars and find out what they have to say about hybrid vehicles presently on the market. So the first thing you need to do is to normalize all the data, and we'll go through in a second what the challenges are in terms of normalization. And secondly, you might want to start classifying and enriching those data. And this stage, the data enrichment stage, is particularly well suited for machine learning approaches. And the third piece here, which is the analysis and insight generation. I mean, this is the piece that everyone on the phone here is going to be very familiar with. It's basically connecting the dots between a whole lot of data in order to reach sound strategic conclusions. So we need the data to be reliable, and we need, the strategic value needs to be based on reliability here. So social media basically, as we all know, represent a huge amount of documents of different types. So just to go through a couple of numbers here, and these numbers are in fact maybe a couple of months old, but they're nevertheless relatively representative of the enormity of the situation. So we're looking at 30 million new blog posts a month. We're looking at almost 2 billion status updates for Facebook every month. For Twitter, we're looking at 4 billion tweets a month, and YouTube, 400 million social actions, whether those are views or shares or what have you. And those are just the quote unquote the primary ways that we might measure those platforms. I'm not even thinking about stuff like blog comments and likes on Facebook, and favorites and flags on Twitter, etc., etc. So it's a huge amount of data. And one of the challenges, I talked about normalization a second ago, one of the challenges is that these documents are all of different types. So documents from different venues will vary significantly. For example, the data contained in a tweet is very different from the data contained in a blog post. One additional challenge of the data collection stage is therefore compiling all of your documents into a minimally normalized format so that at the data enrichment stage, documents from different sources will be susceptible to a common set of data enrichments. And each document has itself a relatively complex structure. First, there's the content of a social media document, what it says on the face of it. Second, and we'll go into a little bit more detail in a second, there's metadata. The data points that the social platform, whether it's Twitter or YouTube or whatever, automatically encodes in each tweet or piece of content to help researchers to understand some of the context surrounding the document. So there's nothing surprising particularly on this slide, and many of you, many if not all of you, will have looked at Twitter and seen a tweet that looks exactly like this one here. So let's know that we're going to be carrying on using the Ford brand as a test case for many of the examples in the remainder of this presentation. So imagine again that we're a marketer in the automotive company. We're trying to figure out what sorts of things we can learn from social data, from social media, about consumer attitudes towards the Ford brand. So if we look at the surface level of the document, we find the data points on the left-hand side. We see who the author is. We see the text that she's posted. We see when the message was posted, and we see a few hashtags here too. And if you were to compile the same data from a large sample of tweets, you might be able to get a sense of something like consumer sentiment towards Ford. This is a simplifying, obviously, but hopefully you get the point here. Beneath the surface, however, each and every tweet or piece of content contains a host of metadata that are just as important as the text that the author has written. So each tweet contains several other points of metadata, pieces of metadata. And the screenshot on this slide is of the Twitter developer console. This allows you to, don't worry, we're not going to go too far down this particular technological rabbit hole, but basically it allows you to query the Twitter REST API from your browser. And the metadata pictured here in the screenshot is the same tweet, effectively, that we looked at in the previous slide. And the information here can be quite informative. If we take metadata about retweets specifically, this gives us a way to understand the degree to which a given tweet struck a chord with the audience. If someone writes something either positive or negative about a product and it gets widely retweeted, chances are other people are feeling the same way as the original author, for example. Metadata like this help us contextualize and better understand the surface level data of the text of the tweet itself. Crucially, however, it also helps us to understand how different social media documents relate to one another. In our example here, we've got metadata about which people and tweets, if any, this tweet replies to. If we chain together such metadata, we get a social graph of conversations about our research topic. Further, it's these metadata that make social media truly social. A tweet or a Facebook post or a blog post is not a document that exists in isolation. These documents are read, commented on, liked, retweeted, and so on. And it's the social life of these social documents that can form the bedrock for insight generation. And finally, probably most importantly from the market research perspective, metadata here can be very important for consumer segmentation. Because tweets, for example, are inherently short, it's often not possible to identify the consumer segment of the poster of the tweet. Looking at the metadata, however, perhaps their bio, their profile, that kind of stuff, you might find out if they're a mom, if they're they're an owner of a particular car, or they're a doctor, or what have you. So it's very important from the market research perspective. So you may remember that earlier I said that much of social media research, the social media research process involves sorting tasks. Let's go into that in a little bit more detail. So if we were to, using our automotive example, if we were to gather the relevant universal tweets about a given automotive brand, we can get insight into that by sorting these tweets and analyzing them according to the results of their sorting, but sorting them by their metadata. For example, if we start off with a huge pile of data on the left-hand side, anything that matches Ford, basically. On the right-hand side, we might want to sort it into 3 piles. Maybe pile A is tweets written by men. Maybe pile B is tweets written by women. Maybe pile C is tweets where the gender can't be determined. Or it could be geographical. A could be tweets written by people living on the West Coast. B could be tweets written by people on the East Coast. And C could be tweets written by people in the Midwest. Of course, we can have more or less piles than 3 depending on the sorting task. Now, we should note this is a relatively simple sorting task. So, for instance, if we take geolocation metadata and think that we saw on the previous slide and think about sorting, there's really no subjectivity involved in sorting this data. A computer can follow relatively straightforward rules to sort tweets based on geographical metadata. Now, the other, perhaps more interesting sorting tasks that we'll look at in this presentation are considerably more complex. So as we said, one of the main challenges of the data collection stage is separating relevant documents from irrelevant ones. And this is one of the fundamental sorting tasks in market research. I mentioned at the top of the presentation that relevant data was absolutely fundamental for the market research use case and perhaps less crucial for the PR outcomes where you're aiming to be comprehensive. So initially, we'll pull in all your documents from the universe of social media that contain keywords that we've determined will pull in what you might term minimally relevant material. And this could require a Boolean approach as opposed to just a simple keyword. However, this universe will continue to include considerable levels of irrelevant material. For instance, spam, documents that are not in the language you're looking to analyze, and potentially documents that from legitimate sources that mention the keyword, but not in a context that is appropriate to the client business questions, or client research questions, I should say. So you might find something where someone's talking about, selling a car or something like that, which is not really maybe of interest to you when you're talking about whether people like the feature of a particular new car. So let's say we've solved the preceding problems. We've got a relevant sample, and the population of social media documents is assembled. So the question for market research is, how do we distill features that we can measure across this universe of documents, and which features should we look at? It really depends on the research question. So if we're looking to understand what a segment of the population thinks about a particular brand, then maybe we're just looking at a sentiment measure here. Is the author making a negative or a positive point about a product or brand? If we want to get more specific, we have to ally that sentiment measure with a metric of with understanding what topic they're talking about. Is it they're talking about let's say the steering wheel or the clutch or the speed or whatever it might be? You need to combine those 2 metrics. If you're looking to understand post-purchase segment, what people think about products that they've already bought, then maybe one of the classifiers you need to use is purchase stage. If you're looking, as we often do, and pretty much always do in market research, to understand a very specific demographic or behavioral group, then you need to find out which segment the document's author is coming from. And then sort of taking sentiment to a perhaps more nuanced level, maybe we might want to look at which emotions are being expressed in the tweet here, or in the piece of content. So there are a whole range of different attributes or metrics that we want to apply or want to analyze the data by. And one of the fundamentals here is figuring out which ones of those attributes or metrics we need to use to answer a specific research question. Classifying the social media message for each of these metrics or attributes is again, it's a sorting task. And given any document, we need to be able to determine which bucket to put it in for each of the metrics or attributes. So for sentiment, we need to figure out whether it's, whether a document or part of the document is positive or negative or neutral. In terms of topics, we need to figure out which topic the document is talking about. Is it the steering wheel? Is it the clutch? Is it the acceleration? Is it the price? And potentially topics that we haven't even predefined. And this is one of the beauties, obviously, of social data, is that you're not just bound to ask questions that you know to ask. So if there are topics that people are talking about that you haven't thought to predefine, then those will pop out of the conversation too. In terms of purchase stage, you might want to do on a binary level. Is it pre-purchase? Is it post-purchase? Consumer segmentations may map to first of all, definitely the sector in particular, and also potentially to the brand too. So in pharma, maybe you're looking at doctor, patient, caregiver, something akin to that. Whereas for cars, you might be looking at current owner, previous owner, future owner, all that kind of stuff. And then emotions, rather than just looking at the positive, negative, and neutral sentiment, you might want to look at joy, anticipation, surprise, disgust, anger, all that kind of stuff. So eventually we need to be able to aggregate these classifications across a set of documents to understand what's going on at the level of an overall conversation, potentially looking at the broader population. And as I alluded to before, we can cut any metric or attribute by any other or cross-tab them. A prime example is cross-tabbing sentiment by purchase stage. So it may be good to know what overall sentiment towards your product is, but there's more insight to be had when you introduce the time element. So if pre-purchase sentiment is largely positive and post-purchase sentiment is largely negative, you've got a problem that needs to be solved, and one that you might not discover until you cross-tab your data in this way. So how can we implement the sorting tasks we've discussed so far? On the one hand, you can have a human handle on all these words, a human handle on all these tasks. You could feed all the social media documents that you have now containing the required keywords to human coders. For each document, the human coder might determine if it's in the right language, if it's spam, and if it's, assuming that the document is in the right language and it's not spam, if it's relevant to deploying questions. And this has the advantage of high accuracy using humans with scalability and cost as potential trade-offs. So if you have a universe of, say, 10,000 social documents that you need to understand, and when I say document, I mean tweet or blog post or whatever it might be, let's say we assume that it takes 1 minute per document for a human to classify. We're talking 160 hours of labor just to classify all this data. And for most researchers in most situations, this is probably too costly. On the other hand, we can use automated solutions for these sorting tasks. So if we can train a machine to mimic a human in sorting judgments, we can make massive gains in speed. And where the human might need a minute or more to classify a single document, a trained machine might make the same classifications in a microsecond. So in the last few minutes of this presentation, I want to give you an idea of just how it is we go about training machines to think like humans so we can achieve these massive productivity and scalability gains. Well, first of all, how do we understand when a computer has classified something correctly? Well, to quote the American Supreme Court Justice Potter Stewart in a case back in the 60s, talking about obscenity, he knew it when he said, "I know it when I see it." And the same thing applies really when we're talking about classifying social data or any kind of task like this. And there are two key points here. First of all, human judgment is the gold standard against which we have to assess the performance of the machine. But secondly, human judgment varies and almost never reaches unanimous consent. So, if human judgment is the gold standard, how do we figure out how accurate it is itself? And the problem is twofold. First of all, for many labeling tasks, there can be legitimate overlap between some labels. And secondly, people make errors in assigning labels. So let's go into some examples here. If you consider the polarity classification, polarity is sentiment. Polarity classification using the labels positive, negative, and neutral on the left-hand side of the table here. While human coders tend to be relatively consistent between one another with respect to positive and negative, it's quite common for them to swap positive for neutral and vice versa, but somewhat less frequently to swap negative for neutral. The problem is compounded even further with more elaborate tasks like emotion classification, when you're not talking about 3 buckets, if you will, but perhaps 8 or 16 or 32 or whatever it might be. You're looking at anger, anticipation, and joy and so on. It's perfectly reasonable that an item labeled as joy by one annotator could be labeled as anticipation by another. If you look on the right-hand side, you'll see the perfectly valid example. Someone talking about an adverb here. One person is disgusted by it, one person is angered by it. And those emotions bleed into one another. Similarly, the other example there, one person sees trust in that, one person sees it as a relatively anodyne blonde tweak, or black tweak. So, one way of measuring measuring intercoder reliability is to use a confusion matrix. and the green cells here, basically on the top left and bottom right diagonal, are where the two coders agree. And what we can do is to derive a raw accuracy score. So we add up the total number of instances where the two coders agree, the green cells, and divide it by the total number of instances to get a raw accuracy score of 61.5. So you can see here that coder 1, for example, thinks there are 548 positive incidents or documents here. Of those 548, however, coder 2 only agrees that 365 of them are positive, thinks that 159 of them are neutral, and thinks that 24 of them are negative. So that's the confusion matrix. As I say, you combine it all together and you can see that the raw accuracy here is about 60%. And this provides the first benchmark against which we can assess machine performance. So put concretely, if we can get a machine to classify documents for sentiment, for example, where a human would agree with its classifications around 60% of the time, our machine will be performing as well as a human being. So this is one thing to bear in mind, obviously, when you hear these claims of our system is 80% accurate or 90% accurate. Is that relative to the human, or is it claimed to be absolute? That's a fundamental question. There's another step, however, in terms of measurement, which is perhaps a little bit more clever and gives us a more accurate picture. So we said before that not all mistakes are made equally. It depends on the use to which you're putting the data. In most situations, it's potentially worse to mislabel something something positive as negative than it is to mislabel something positive as neutral. And this is true for both a human or a machine coder. And we can factor in these relative weights by using what's called Accredit Matrix. And the one on the screen here says that you get 100% when your label agrees with the gold standard. So if you call something negative that the gold standard says is positive, you get 0 credit. If you make a really bad error, but if you call something positive, the gold standard says is neutral, you get 50% credit because it's not such a bad mistake. Once we have this credit matrix, you can multiply the confusion matrix by this credit matrix to derive what might be called a partial credit figure of merit. And ultimately, this new figure establishes the baseline against which we measure the performance of the machine learning algorithm or of the automated classifier. So if you imagine that the automated sentiment solution didn't have negative, it would still be right a lot of the time when you've got a conversation which is largely positive. But using it, obviously, but that's in practice, it's not particularly useful. So using this partial credit figure methodology helps to distinguish between automated systems because it means that big errors like that are identified and punished. So, okay, well now we have an idea of how it is we evaluate whether or not a machine is performing well. But how is it that a machine actually makes its decisions? And this is a subject, obviously, of entire PhD courses of study, so it's not something we can do any justice to in closing this presentation. But nevertheless, we can get a basic overview by just understanding the key machine learning technique. So first of all, you've got your collection of human annotated data. And the second step is for the machine to look at all the records, for example, that are classified in the data set as positive. And across these documents, it will find recurring patterns. Could be single word, could be combinations of words. The central point here, they're patterns as opposed to just using word spotting. If some combination of words occurs in a larger number of the positive documents, it's a stronger probabilistic indicator of positivity. Step 2 is an iterative process, and the machine model can be continually refined. The more training data, the better the machine's model will get. And this is very distinct from using a set of human-defined rules that we create, which you might call word spotting, where this is the type of thing where you just look for love or hate or something akin to that. And in step 3, the machine applies this model, this probabilistic model, to new data. So for any given document that it sees anew, it looks for the patterns it saw in step 2 and analyzes the document for the presence of those patterns to reach a decision about how to classify that document. And it will assign a classification to indicate how confident it is in that classification. Human coders then can then assess the annotations made by the machine, and the model can get further tweaked until the machine is able to approximate the performance of human coders. And obviously, the larger your training set, the more accurate your machine is going to be. And obviously, we're talking about sentiment here, but pretty much anything that you can, anything that you can code that a human can code for or parse data for, could be turned into a machine learning algorithm given enough training data. So, as I say, I focus on sentiment. You could just as easily, with the right training data, focus on stuff like impulsion or purchase stage, or a number of the other attributes we've talked about here. Gender, for example, might be an interesting one to do, and I know there's been some work done on geolocation, inferring location from the text of the tweet or the text of the piece of social content. So to conclude, in terms of what the approaches you might take in terms of enriching data are when you're looking to use social data for market research. First thing is to make sure you're actually looking at a market research use case rather than a monitoring one, as I've deemed it before. So you're not looking at PR or comms. The second one, most crucially, is consider the research or business question that you're going after here, and make sure you select metrics that speak to your objective. And there's a corollary here in traditional market research, which is you choose the right questions to meet your research goal. And it's exactly the same in social data. You need to look and select the right attributes that you want to apply to the data to make sure you've got the right attributes to answer your research question. The third point is make sure you take advantage not only of the text of what people say online, but also the metadata, the additional information most social media documents contain, because it's a treasure trove of information that can add context to the market researcher. And then fourth, if you're looking to scale this out using machine learning, it's worth bearing in mind that machines will rarely make perfect decisions, but with enough training data, we can help them get to a place where they're much more accurate than you might think they could be. So there we go. Any questions?